Good evening, everyone. So, so this is a chemical bonding practice session. I already discussed the two. I already discussed chemical bonding, molecular structure chapter, half of the chapter, not full. As I already told you that this chapter, we are dividing this chapter into two parts: chemical bonding and molecular structure. So I just discussed half of the chapter, so I just need to discuss the practice questions, because there we just focused mainly on the reading part and listening part. I mean to say explanation, and we did even few questions, but still there are many questions to be done, and there are chances of questions from this part, that is chemical bonding. That's why we are going to practice today that chapter, half of the chapter, obviously. So the name of the chapter is chemical bonding, molecular structure, NCERT extract objective. If you have the PDF, you can open, as I think I have shared this PDF with many of my students. Those who do not have this, please get it from the Spark Academy staffs. They'll share with you this PDFs, like Arihanji means NEET chemistry PDF and NCERT extract objective. And this, I find this book, which is NCERT extract objective, excellent for practicing. So make sure that you keep this three at least, NCERT extract practice PDF. So let's do this. So the first question we are going to do this is, the attractive easier questions will start. The attractive forces which holds a various constituents, it can be atoms, ions, etc., together in different chemical species, is called as. So what do you call the compound is held by a force? So what do you think the name of the thing is? What do you call? It's called as chemical bond. It's called as chemical bond, or chemical compound, ionic bond, or covalent bond. So what do you think the answer is? Just wait a minute. I'm on live. Sir, it's showing started, but it's not, coming on the YouTube. Please just check now.
Okay, ma'am.
Okay. So sorry for this disturbance. Let's continue with the first question. So what the first question I asked, that attractive force which hold the two various constituents together in different chemical species is known as chemical bond, ionic bond, chemical compound, covalent. covalent bond. So see, to define ionic bond, we have, to be called as ionic bond, we should have a definition that the bond formed by transferring of electron. Covalent bond के लिए sharing of electron chemical compounds not, because they are talking about force. So the answer is A, right? That means the answer is A for this, that is chemical bond, right? So let's continue the next one. So I'll just skip those easier ones. The first one itself was easiest. Let's talk about this 12th question. What is the 12th question? You know what? Which of the following does not represent the correct Lewis structure? They're telling that which of the following does not represent the Lewis dot structure. So let's do the first A option. You see that chlorine here, one more chlorine here, and there are 4 electrons in the bond. You see, this is known as bond, right? I hope you know the Lewis dot structure. So you can see that the chlorine are forming 2 bonds. I already told you that chlorine forms only 1 bond. So you can see that they are forming here 2 bond. That means A is definitely the wrong answer, right? But there are options like you see A, B, C, and D1 is A and C. Let us just check B. What do you think B? So oxygen atomic number is 6. So here one involved in the bonding, right? This, I would say this is B's, right? Let us just check with the C1, which is carbon dioxide. Yes, CO2 is carbon dioxide. So carbon dioxide is here C, and oxygen here. This carbon is forming 2 bonds with this oxygen, 2 bonds with this oxygen. I would say this is right. So answer is A only. So the A is the wrong representation. That means A is the answer for this. Let's talk about the second 7th one. Cation and anion combines in a crystal to form following type of compound. So when the cation and anion combines, what is the bond forms they are asking? So cation and anion nothing but ions, right? When the ions are combined, the bond is known as ionic bond. That means the answer is A for this, right? You can even answer the question if you're watching this. Let's skip this Lewis dot structures. These are easier only. I'm just moving to the 15th one. In N2 molecule, that is nitrogen molecule, 15th one. In N2 molecule, the number of electrons shared by each nitrogen atom is. So they are telling that between this. So they are telling that between 2 nitrogen atoms, how many electrons are the number of electrons shared by each nitrogen atom. So each nitrogen atom is sharing how many electrons they are asking. Do you know, I told you in the chemical bonding concept that nitrogen forms 3 bonds, right? Somewhere else I told you in the chemical bond, covalent bond, you can see that here nitrogen is forming 3 bonds, right? Nitrogen is forming 3 bonds means each nitrogen is sharing its 3 electron. That means the answer is 3. Let us just check where is 3 is coming. So I would say C is the right answer, because here would say because nitrogen shares only 3, right? Let us just check 16th one. Again a Lewis dot structure, but this is representing in the form of cross lines. So we'll do that one. So which of the following is a Lewis structure of nitrogen molecule? So you got that between two nitrogens, there are 3 bonds, right? So you can see that we'll just neglect the one which is wrong. In exam, you please do like this only because we have very less time. N2 forms 3 bonds. You can see that here C is forming single bond, here D is here of forming 2 bonds, which is wrong. So C and D are totally wrong. I hope the thing was on. I mean mute. What do you think D? So oxygen, your atomic number is 6. So yeah. So we'll delete C and D as they are forming 1 and 2, which is not possible. Now nitrogen A and B forming 3 bonds, right? Which is right. But let's just check. Do you know nitrogen has how many lone pairs in the outer when it is forming 3 bonds? Do you know? Atomic number of nitrogen is. Let's just check how to do that. So atomic number of nitrogen is 7. 7 means first shell contain 2, second shell contain 5. That means nitrogen has only 5 electron in the outermost shell, right? So if it is forming 3 bonds, like 3 shade, so one will be one pair, that is 2 electrons will be left. They are called as pair electrons, or usually we call them as lone pair electrons or non-bonding electrons. Both non-bonding electrons, you can say non-bonding electrons, right? So that means nitrogen has 1 lone pair on each nitrogen. Let us just check which one is matching with this representation. So you can see here the A, that each nitrogen is having one lone pair nothing but 2 electrons. You can see that B, here nitrogen is having 2 lone pairs, which is not possible. When the nitrogen forms 3 bonds, it will have 1 lone pair left, that is means 2 electrons left. That means the answer is A. So the A is a correct structure for nitrogen, right? So we'll skip that Lewis dot structures, which are easier. We had to do at least one, that's why we did 1 or 2. Due to the next concept which they're asking is formal charge. I couldn't explain in the formal charge in the notes explanation in this way. I would just want to discuss this point, which is very easier only. So you please need to memorize the formula for formal charge, which is like very easy. So you know what is formal charge? Let's define this first. Charge, the name says we are going to find out some values charge here. Formal charge is nothing but the charge on each atom in a compound. So if you have a compound nothing but more than 2 atoms, right? If you have a compound, on each atom what is the charge, if you want to calculate, you can calculate formal charge. You will be thinking that what is the charge. Example, like if you take H2SO4, and what is the name of H2SO4? It's sulfuric acid. If it remove acid is a molecule which can release H plus, right? So if the molecule is releasing or removing all the H plus, it will be like SO4 minus 2. This charge, this SO2, this minus 2 charge, we say that minus 2 is on a whole molecule. But if you want to calculate the charge on each atom, if you want to calculate the charge for sulfur separately, 1 oxygen, 1 oxygen, 1 oxygen, 1 oxygen, each charge if you want to calculate for each atom, that means you need to calculate formal charge. So how to calculate formal charge? The formal charge formula, there are many formulas. Obviously all formulas will give you the right answer, but you can memorize only one. So the formal charges here is equals to the number of valence electrons. So valence electron, you know, outermost electrons, right, minus number of non-bonding electrons minus of bonds by divided by 2. So if you want to calculate formal charge, the formula is valence number of valence electron minus number of non-bonding electron minus bonds by 2. Let's do one example with this and you will get a better understanding of this. The molecule like which is famous for calculating formal charge is O3. O3 is nothing but, you know, that is ozone, right? So if you want to calculate the ozone, each oxygen charge in the ozone, you need to first draw the this structure for ozone. You know that there are 3 oxygens here, right? So let me just check whether I'm drawing right. 1 2 3 4 5 6 7 8, right? 1 2 3 4 5 6 7 8, right? 1 2 3 4 5 6 7 8. So this is your ozone. So I will write this oxygen as one oxygen, first oxygen. I'll write this oxygen as second oxygen, and I'll write this oxygen as third oxygen. Okay, you can represent any way. You can go right from left also, it's not an issue. So let us just calculate the oxygen charge on formal charge of the first oxygen. Okay, so the formula for formal charge, number of valence electron. How many valence electrons are there always? Atomic, let us just do here. Oxygen atomic number is 8. 8 means first shell contain 2, second shell contain 6. So that means always nitrogen will have 6 electrons in the outermost shell. That means valence electrons are always 6. Second is minus of non-bonding electrons. How many non-bonding electrons are there? 4, right, minus of bonds by 2. It's forming how many bonds? 2 bonds. 2 by 2 is 1. That's you get the 6 minus 4 by minus, I think 200, that is say you will get the oxygen valence here as plus lone pair. Wait. It's let me just check with this. I wrote non-valence electron minus non-bonding electron minus bonds by 2, right? Oh, total number of Z by 2. Wait. Here it is. So I'll just correct this. You can write anyway. I'll just correct this. I will write as bond electrons here. Bond electrons. Okay. So that is. So wait, it's 4 minus how many bonds are there? So you should not get 0 valency. It is like 6 0 you're getting. Yeah, okay, we'll do that. So the valency for the oxygen in this case is 0. So I'll write as 0. right? Yes, so this is right actually. I'll just delete that. That is number of valence electron minus number of non-bonding electrons minus bond electrons, right? So 6 is always here. Let me just write the valence electrons. 4 here indicates the non-bonding electrons. Here this indicates the bond electrons. Okay, so this is, that means I got the oxygen valency as 0 for the first, that is 0. Second, let us just calculate the second oxygen valency. Always 6 will be the thing, because valence electron in the atom will be same. If the atom is same, if the atom is same, the valence electron will be same. Minus, here you can see that now non-bonding electrons are 2, right? So I'll write as 2. Minus of this will be here, how many bonds, 1 2 3, so I'll write as 3. So you will get as 6, minus 2 minus 5, you will get something around like plus 1, right? 6 minus 5, yeah, plus 1. So that means the valency for the second oxygen is plus 1. Here I got 0. Let us just calculate for the third oxygen, which is this oxygen. Let us just write electron as 6 always. Here 1 2 3 4 5 6, 6 minus 6 get cancelled. Still we need to write this here. It will be 1. That may, because it is forming one bond here, so it will be 6 plus minus 6, it will be minus 1. That means here you will get minus 1 valency. That means each oxygen is showing different valencies in, what do we say, in ozone molecule. So for this oxygen is forming like 0 valency, middle oxygen is forming plus 1 valency, and the here oxygen is forming minus 1 valency. You can see that each oxygen atom is showing with different valencies. So if you want to calculate the different valencies for each and every atom, you need to calculate charge. I hope you got this. Let me just correct this again. Let me just rewrite this. I would better write as bonds. So hope you got this. Let us just check the formal charge concept, which they are asking in our practice book. So what is xyz in the following expression of formal charge, f in the Lewis structure? So for they are telling that formal charge is x minus y by minus 1 by 2 z. I did not give you the formula by 2, right? I just corrected that. We'll just see with this math what is, which option is matching. X is what? The number of so x is not number of total number of non-bonding electrons. No, x always will be the number of valence electrons. That means A definitely will be the wrong answer. Let us just check the B. X indicate the total number of valence electron in the free atom. Yes, x can be the total number of valence electron in the valence electrons. What is V? We said V is nothing but non-bonding electrons. V is here, they are telling Y. So they are telling that Y is number of bonding electrons. No, will not do that. Right, no, B again will delete that B, which is not matching. C, let us just check C, total number of valence electron in the free atom. Yes, X is going to be right. But just check Y. Yeah, Y is non-bonding electrons. Yeah, Z is the bonding electrons, right? So I would better write this, not better actually, these are two ways of writing as they are giving. So instead of telling bonds, they are telling here that you can even write as bonding electrons by 2, right? Bonding electrons are how many here? 4, right? 4 by 2 is 2 only. So you can see there are two ways they are writing, but understand the concept, that's all. You can write any way. That means the C is going to be the right answer for this, right? Because I said the last one is bonds. They are telling that bonding electrons by 2. They are dividing by 2, right? Z, they are dividing by 2. So bonding electrons will be double of the bonds. That's why they are dividing by 2. They both are the same ways. Let us just check. Oh, octet rule. Do you remember I even told you the octet rule limitation? There are almost 6 or 7 octet rule limitations we have. Let us just do 24th one. 24th question. So, which of the following molecules the octet rule is not followed? Which of the following molecule is not obeying octet rule? You can even say NH3. No, NH3 nitrogen atomic number is 7. 7 means 2 and 5. 5 means it is forming 3. 3 means 6 electron. 1 will be there. Yeah, A is following octet rule. That means A is not the right answer. B, CH4 carbon. Carbon atomic number is 6. 6 means 2 and 6. 2 and 4, sorry. 4 means that's why it is forming 4 electrons. 4 electrons means forming 4 bonds. That means 8 electrons. It is following octet rule. CO2. Yeah, carbon dioxide again follows octet rule. You can see the NO, right? Nitric oxide. Do you know NO is known as nitric oxide, which is known as laughing gas. That means if you inhale this gas, you start laughing it. Still, let us just do why NO is not obeying octet rule. Oh, even I told you that in the octet rule limitations, right? Even I gave the exact example for this. Yeah, it's here. You can see that octet rule. Limitations of octet rule, the one example I gave were presence of odd electron, NO. You can see that nitric oxide, which is NO, is having odd electrons. It is not having 8 electrons, the outermost shell. So that means NO is a molecule which is not obeying our octet rule, right? That means where is answer? Yeah, D is the answer for this. No one is answering. Please, those who are watching, please answer. We have already discussed this, right? Let's do 27th one. We'll do faster now because I'll not. I'll just give the short explanation for the answers because I already discussed the thing, and I thought I'm even thinking to start the questions which have been asked in your name, J mains and NEET. Let's do fast. Among the 27th one, among the following, the electron deficient compound is electron deficient means which have no electron, right? I even told you the octet rule limitation that incomplete octet of central atom. This is only shown by the molecules which have less than 4 electron, the outermost shell. That means you need to pick up the one which have 4 less than 4 electron, the outermost shell. So I already told you that 13 group are always having less than 4 electron, the outermost shell. That means the answer is BCl3, because BCl3 is the molecule which belongs to 13 group. Boron belongs to 13 group, right? CCl4, no, 14 group. PCl5, 14 group. D, that is D is beryllium. Beryllium is having 2 electron, the outermost shell. It's almost like stable kind of molecule compared to the boron. That means A is the right answer, which is BCl3. Please remember 13 group are known as Lewis acid. They are electron pair acceptor. They are electron deficient molecules. Let's do the similar questions. Which of the following is electron deficient molecule? C2H6, SiH4, B2H6, D. What do you think the answer is? Which of the following is electron deficient molecule? Again, boron came here. That means the answer is going to be the B, because boron belongs to 13 group. Oh, it's 29th. Let's do 29th. What is 29th? Which of the following molecule does not follow the octet rule for electron distribution? So when the electron is distributed, they're not following the octet rule. Do you remember I have told you that certain molecules having incomplete octet not following octet rule, presence of odd electron, presence of extra electron. Extra means more than 8. More than 8 means like 9, 10, like this. Let's see the example like PCl5. PCl5 means phosphorus is 5 bonds. When the 5 bonds are there, it means 10 electrons. 10 electron means more than 8. That means the answer is going to be A, right? See, almost the question which they are asking in the practice questions paper as from the PDF, explanation which I gave you in your class classes. So I'm even following that NCRT, and what I'm giving those examples which is mentioned in NCRT only. Obviously I'll give extra, but definitely from the NCRT. इतना तो पक्का है NCRT, from NCRT I'll be giving the exact points and as well as examples. Oh, let's do that 30th one. A pair of compound which have the odd electron in the group NOCO, ClO2, N2O5, SO2, O3. Please remember, I already told you that nitric oxide, which is NO, is having odd electron in the outermost shell. You can see the example I gave here. So odd electron. So pakka we got the NO. Let us just check. Oh, even don't need to pick up the CO, ClO2, N2O5, SO2, SO3, because option A is only matching, is only the compound which is having NO, right? So we no need to know that Cl2 is having odd electron or not, because it's not given in NCRT also. That's why there's a hint here how to know the answer, which is how to know the answer is NO. We know that NO is having odd electron, so pick up the one which is NO having NO. That means the answer is A, right? I hope you got the explanation for this and you got the how to pick up the right answer. So 36 also will do. 36 is having some new question. Which of the following combination will form an electrovalent bond? Do you know what is electrovalent bond is known as? Electrovalent bond is known as, my dears, those who are watching, please answer what do you mean by electrovalent bond? Oh, no answering. Electrovalent bond is nothing but ionic bond. So they are telling that which is the following compound when you mix they form an electrovalent bond. Let's do one thing. We'll go from the old timing like DCBA. Okay. Sometime we should go like this. So let's see. D is having hydrogen and sulfur. Hydrogen belongs to it even belongs to P block. S block also it belongs, but scientist says that hydrogen belongs to S block partially, P block partially. So consider as of now like P block, here S, P block, both are P block. So we can't say P block form ionic bond. Let's do that C1, hydrogen and calcium. Hydrogen is considered like P block, calcium is D block. Do you remember I told you D block and P block? Told you, look here, the first class itself I gave you the ionic bond things. So yeah, so if you want ionic bond, please mix any bond, any S block with P, any D block with P, any F block with P. I already gave the explanation. You can see that. So here you can see that consider hydrogen is like P block, calcium is like, obviously calcium is D block. So D and P, answer is ionic bond. That means C is the right answer. Got? Oh, among the following, which shows the highest lattice energy. So do you remember I told you the concept of lattice energy? Lattice energy is the molecule which is released during formation of ionic bond. That means more the ionic bond, more the ionic character, more the lattice energy, right? So because ionic bond only having lattice energy. So if the bond is a stronger ionic bond, having highest lattice energy. So what do you think the answer is? A, B, C, D. How do you know that which has high lattice energy? Do one thing, calculate the one which is find out the one which is having more ionic character. How do you calculate? How do you calculate that it has more ionic character? How do you know that it has more ionic character? With the help of the thing known as Fajans rule. So what Fajans rule says? Fajans rule says that it describes about the covalent nature of ionic bond. So covalent nature is directly proportional to anion size, directly proportional to charge, inversely proportional to cation size. So if you are calculating covalent nature, you can automatically calculate ionic nature, right? So reverse is the case for ionic. Let's find out the answer for this. KF, NAF, KCSF, RBF. Let's do one thing. We neglect FFF, right? Because F all are having FFF. Even the cation charge is also similar. So you can't even say in the based on the charge. You cannot even say in based on the anion size, because anions are same. So let's do, how do we do? You can see that here potassium, sodium, cesium, rubidium. During the elements, these belongs to alkali metals, right? Examples for alkali metals are lithium, sodium, potassium, rubidium, cesium, right? That means cesium is coming in the extreme side, sodium is coming in the first side, I mean almost first, top. So down the group atomic size increases. If the cation size is increasing, covalent bond nature is decreases, right? That means cesium cation size is more, covalent nature is wait, let's yeah. So cation size is more, covalent nature is less. So what do you think the answer is? The answer is cesium is the one which is having highest cation size. More cation size means less covalent. Less covalent means more ionic, right? That means the answer is cesium fluoride, because it is more ionic, right? That means the answer is CSF. Oh, next one is which of the following bond having the highest ionic character? Please remember, if they are asking you ionic character, if they are asking covalent character, please remember Fajan's rule only. Fajan's rule only will help you with this highest ionic character. HI, HF, HCl, HBr. HH will cancel because all of them, having HHH. Charge also will cancel because all of the halogens have -1 charge. Iodine -1, fluorine -1, chlorine -1, Br -1. So we'll delete them charges also. Let's talk about that anion size. Fluorine, the sequence for halogens is fluorine, chlorine, bromine, iodine, right? Fluorine, chlorine, bromine, iodine. So more the anion size, more covalent. More anion size is of iodine. Fluorine, chlorine, bromine, iodine. Iodine is the most having more anion size. More anion size, more covalent. But we want ionic. That means ulta. That means the answer is HF. Right? And even Fajan's rule, dipole moment even says more electronegativity, more dipole moment. That means the answer is HF according to dipole moment, also according to Fajan's also. Right? Oh, hope you are getting this. These are easier, right? These are easier. Let's do 44th one. 44th, complete the following statements with A in bond character, B increases and C decreases. So they are correlating bond order, bond length, bond dissociation. Enthalpy is nothing but bond dissociation enthalpy. I hope you remember those things which I talked about, the bond parameters. Where are they? I already discussed this. I gave the I told you, right? Bond order is directly proportional to stability, directly proportional to bond angle, directly proportional to bond dissociation enthalpy, inversely proportional to bond length. All the things related to bond will be directly proportional to bond order only. The only thing which is inversely proportional is bond length. So bond length is inversely proportional. That means bond order increases, bond length decreases. So let us just check which one will match with this. So A, just check with the A option. Bond order increases, bond length increases. Oh, see, the option A is telling that A is increasing, which is bond order increasing. So B is telling that bond length also increases, which is wrong, because we said bond order, bond length are inversely proportional, right? That means A is not going to the right answer. If one increases, the other should decrease. B, just check. B is telling that A is increasing, that is decrease in bond order. Bond enthalpy increases. No. Obviously we'll delete that B. Yeah. So let us just check with the C. Isn't it a CI is the right answer? Check with the C. C is telling that A is increasing, that is bond order is increasing. Bond length is also bond enthalpy is increasing, whereas bond length is decreases, right? We know that decreases is the one which bond length. That means C is the right answer for this. Oh, see the question 45 question 45th question, which is the following have the same bond order. As of now, while you know that between two atoms like HCl2, H2N2, Br2, they have single, double, triple bond, all this thing we know. Still, if they ask you any molecule which you don't know that bond order is how much 1 2 3, we'll be going to, we'll be reading that how to calculate bond order in the next half of the chapter, that is from tomorrow itself. I'll be starting those parts. So as of now, I think we know that which has the bond order 1 2 3. Hydrogen atomic bond order is 1, chlorine is again is 1, carbon monoxide is 2, Br2 is 1, N2 is 2. They are telling same bond order. So chlorine is 1, hydrogen is also 1, nitrogen, bromine is also 1. Choose the correct option. 1 2 4, right, we got the answer, have the same bond order, right. The answer is A, we got with the first explanation itself. 3 and 5 have the same bond order. 3A is carbon monoxide, which is having 2 bond order. 5 is nitrogen, which is having 3 bond order, which is totally wrong. That means A is the right answer. So we no need to go for the further options, right? Let's do few questions from Arihant. This is JE mains. We are going to even do that NEET questions. Oh, I got the question, which is 12th one. So please we'll do the 12th question, which was asked in your JE mains 2018. I'll hide the answers. So 12th question, which of the following compounds contain no covalent bond? Which of the following compound does not contain covalent bond? KCl, PCl3, PH3, O2, B2H6, H2SO4. They should not be covalent bond. If there is a no covalent bond, definitely that should be ionic bond. So you need to pick up the molecule which is ionic. Ionic bond is formed by combination between NES block to P block, D block to P block, and F block to P block. Please identify the one which is ionic bond. So what do you think? The answer is KCl, PCl3, O2, B2H6, H2SO4. I would say KCl is ionic bond, definitely. But you just see here options like B2H6 is there. B2H6 boron. Boron is P block. Hydrogen is again P block. No need. That means O2, oxygen is two similar atoms, so definitely will form covalent bond. That means O2 is also will delete. B2H6 again. PH3 covalent bond. H2SO4 has coordinate covalent bond also and covalent bond also. That means we'll delete all the things. We have only C, KCl is the right answer. Let's do JEE Mains 2017 asked question, which is your 14th question. They are asking us to calculate the one which is having isoelectronic species. Do you remember I told you about the isoelectronic? Iso means same, electronic means electron. The species or the molecule which have same number of electron are called as isoelectronic. So you just need to find out the one which is having isoelectronic species. So O minus 2, F minus Na plus Mg plus 2. Do you think what do you think the answer is? O minus 2, oxygen atomic number is 8. 8 minus 2 means 10. Fluorine is minus 1, 9. Minus 1 means 10. Sodium is 11. Plus means lost, 10. Mg plus 2 is 12. Mg plus 2 means 12. Magnesium is 12. Plus 2 means loss of 2. That means I'm matching with the A, isn't it? You can see the JEE means as question. Even we're going to do the NEET also. Don't worry. There are also new NEET students here. I found one more here question. There's a one more question to be done. No, so we can't do that question because the part topic is not yet completed. I'll be covering those part soon. Let's do one more with this, even a type AIEEE 2011 asked question, which is 22. Which of the following has a maximum covalent nature as shown with FeCl2 is SnCl2, AlCl3, MgCl2. Chlorine will delete because anions are same. Charges if you want, iron here is plus 2 charge, Sn here plus 2 charge, AlCl3 and Mg plus 2. Do you remember we told you here? For Janssen, covalent nature is directly proportional to cation size. Sorry, directly proportional to anion size. Charge inversely proportional to cation size. You can have a look here that iron here is Fe plus 2. Yeah, iron here is Fe plus 2. In the A, B is also like Sn plus 2. C is AlCl3, means aluminum is plus 3 charge. D is like MgCl2, that means magnesium is having plus 2 charge. So one which is having more charge will be more covalent, that means the answer is C. Right? रोहिना जरा आवाज. So that question let's talk about dipole moment. Let us just check whether we can do or not dipole moment. We already discussed the dipole moment, right? Which of the following compound having significant mu is not equal to 0? Significant means some values is there, some value will be there. Mu not equal to 0 means dipole moment should not be 0. Here you can see that benzene attached to chlorine, benzene attached to chlorine and CN, benzene attached to OH and CN. Let me tell you, this concept slightly belongs to organic chemistry and as well as inorganic chemistry. This concept belongs to both. So the dipole moment came, so I'll be discussing here. I'll do one thing. I'll just draw these structures. Wait, I'll give you with the better explanation. Just wait a minute. uh, see, they want us to calculate which of the following molecule is having significant dipole moment, means some values should be there, not it should not be zero. So this belongs to both organic and inorganic. I'll draw this first. You can see the one common thing here is they are all attached to benzene. Do you know when the benzene is attached to any group, the two groups can be at groups can be two types. Sorry, whenever any group attached to benzene ring, they get divided into two types. Some of them donate electron to the benzene ring. That means they act as electron donating group. Some of them withdraw electron from benzene ring. Based on this concept, you are going to solve this question. And please remember this. This will be helpful for you when you study organic chemistry. So whenever benzene attached to any group, like consider A group is attached, this A group can be electron donating group, it can be electron withdrawing group. You need to memorize those groups examples. Electron donating here is halogen, carbon chain, that is carbon, any carbon attached, OH, NH2, SH, OR, always they are always donating group. Withdrawing group, whatever the groups were left, means like nitro group, NO2 group, cyanide group, carbonyl group like aldehyde, ketone, carboxylic acid, amide, esters, all of them, these are different, SO3H, all of them are withdrawing group. And these are only the donating group: halogen, carbon chain, OH, and H2SH. Let us just check. Based on this, we can calculate dipole moment. So chlorine is halogen, right? It donates electron to the benzene. That means the head of the arrow will be towards the benzene. That means here the arrow is one is down, one is downward, and again is up. This, right? Yeah. Now just here towards chlorine, here towards cyanide is withdrawing group. So I will, no, they will cancel. No, cyanide को भी you please, yeah, cyanide, you please keep here. Cyanide will be again this group, so please you put here. So up. Here you can see that OH. Did I tell you OH? Yeah, OH, I told you that it's donating group. It's giving electron to the benzene ring. Here it is giving towards the benzene ring. Here it is towards the benzene ring, towards the benzene ring. Down, it's down, it's up. What do you think? Which one you say the answer is? Significant dipole moment. Yeah. So what do you think the answer is? Let me just check what explanation actually they are giving. Chlorine, they are telling it's withdrawing group. Cyanide is. Oh. I'll just do some small changes here. I'll tell you. I think I just need to tell you that exception here. Please remember, halogen is dual nature. That means it has a tendency to attract bond electron towards itself. So based on this only, I think we can solve, right? So I'll just Oh, yeah. So please just just I'll do one thing here. I'll better draw here itself. So please remember that whenever any group attached to benzene ring, they will be acting as electron donating or withdrawing. This whenever any group attached to the benzene ring, it can be electron donating group, it can be electron withdrawing group. Donating groups donate electron to the benzene ring. They are like R, OR, and OH, and like SH2, or I mean, if it is SH, yeah, it is SH, and here it is like nitro group, cyanide group, any carbonyl compound like carboxylic acid, aldehyde, ketone, as well as like SO3H. Please remember these are withdrawing group. So I'll just do one thing. Halogen is a both but majorly you can say that here it attracts electron toward itself. Benzene electron is getting attracted towards chlorine. So I would say that here it is down and down. So up and down. That's why they are cancelling the dipole moment. That means zero dipole moment is seen. Up and down. Though they are up and down, they'll not cancel. That's something least value, some not cancelling because they are not similar compounds, but still it will be near to zero or very less, I can say very less, because but they are asking us significant means some below big value should be there. OH is what OH is, I told you that it's donating group, so it's donate electron to the benzene ring, so it will be downward. Here it will be upward, downward, and upward it's coming, and here it is towards benzene ring. SH is again like donating group, it's give here upward, I mean so downward and upward. They are not cancelling the dipole moment unless they are in opposite direction. Arrows should be in opposite direction. So please remember, don't think that these are cancelling. Definitely the thing which are in opposite in arrows, like this down, this they can cancel, right and left get cancel, but not this one, not this one. Okay, right, this will not get cancelled, so these are not cancelling the dipole moment. So I would say third definitely will have a value. Fourth also will have some big value because it is SH. So I would say fourth is a major, but the options are like 4 and 3, only 3, no, only not only 3, C and D, I mean third and fourth are showing some big values. That means I would say D is the one which shows uh, dipole moment, right? I hope you got this. Still, if you're not getting, leave it. This part is all somewhat belongs to organic chemistry, so if you're getting, it's okay. If you're not getting, no problem, because this part is somewhat related to organic chemistry. I hope you got the questions which we have discussed today. Any doubts you have? So no doubts, we'll end the class, right?